When you hear AI and cancer, what comes to mind? Maybe it's, another tech buzzword. Or maybe, does this mean faster answers and earlier detection? I mean, what if you had a blood test that detected circulating cancer DNA, but no doctor could find the tumor? My guest today, Pete Martinez, has spent the last 12 years building AI systems that have already helped 162,000 patients get more accurate diagnoses, including rare and genetic cancers.
What we're doing is amplifying the brain to be a super brain of taking a look at the whole human body as an entity, not in very fragmented pieces.
So that's what we're exploring today on Kicking Cancer's Ass, how artificial intelligence is already being used by geneticists and doctors to find and diagnose rare cancers earlier. Let's get started.
Let's understand what the basics are of artificial intelligence. A lot of it, there's a little bit of confusion about what it is and what it isn't. Think of the most powerful computing system in the world being your brain. It's the size of my fist, and it does a number of things that computing systems today don't do very well. And let's break it down to three, and we'll use just plain English to describe those. The first is pattern recognition. Our brain does something magnificent that we can actually recognize patterns across visually, audio, and in the written form. Our computer systems do a pretty good job right now of recognizing our text and drawing similarities of it. They're actually doing pretty good related to speech recognition. We're not doing that well in terms of images just yet. But pattern recognition, hold that thought. The second one is reasoning. Our brains do what we usually term as contextualizing. How do we determine when we say the term hot dog? It could be three things. It could be a food, it could be an animal with a temperature, or it could be somebody who likes to show off. How do we know that? That's actually the reasoning that our brains do and very, very fast. And the third thing that our brains does is learns from every transaction, every experience that we go through, it learns. So you put those three into an AI expert system, and that's exactly what we want to accomplish. So think of an expert system in this case being we take the mind of an expert, a highly skilled individual. In this case, we'll use genomics, a highly skilled geneticist, and we put his brain thought process into algorithms. So every decision that they would typically make, right, wrong, if and there, it's codified into algorithms. And therefore, one, we codify the process, but second, to what the AI does, which is magnificent, we're able to bring much, much more data than what individual could possibly absorb in their lifetime. And we can do it in real time. So all of the most relevant, most contextual information can be integrated in real time and providing a much broader swath of information that we can work with real time and certainly a whole lot more accurate than humans can deliver. Yeah.
Explain how this expert system applies to cancer and when somebody needs an expert system beyond their pathologist.
Consider that there are four different areas of interjection with cancer. The first one is preconception of the parents. You can actually determine the probability of somebody in their lifetime picking up cancer, primarily because of the inheritance in from their parents. The second one is post natal, once a child is born, the whole concept of doing determination, proactive screening for genetic conditions or symptomatic conditions, whatever it is. The reason we put so much emphasis on genetics is it's the architecture of the body. Everything about your body, current and future, is in your genes. So, to the degree that we can actually identify predispositions early on and the likelihood of things happening, that's where the AI starts kicking in as well. Because now you're able to take multiple factors into being, not just the genetic information, but you can actually start capturing some biomedical information, some phenotypical or clinical observations and come up with a much greater composite. The third is, so what do you do in terms of early treatment or early detection? Okay, so one is predisposition, the other one is, okay, now I can detect it. And detection is in multiple areas. One, related to imaging. We can actually detect some cancers related to imaging, and some biomarkers, some fluids that we take, and then some symptoms as well. We've been running some analysis using our AI, and you know that there's a relationship between uh, parental or inherited cancers and blood from the mouth, bleeding of the mouth. I said, What? So this is where the pattern recognition starts coming in, that you might be able to detect some things from symptoms that are not the obvious ones that we would look for cancer. This is why this large data models become very, very critical. And we're working on some very large data to actually look for those correlations. We can actually inject the algorithms, the variables that we have, and now start doing the deep dive. But then the fourth element is actually the treatments. We know that some medications, some treatments will be more applicable to some than others. So what we're getting into now is the personalization of medicine, and this is both the predictive and preventative action related to it. It's four different elements where AI is really going to kick in very, very quickly, and this is where I'm so hopeful here. It's one in the predisposition, prenatal, postnatal, the identification and the treatments related to it. So what we're working really, really hard on is creating the integrated model of not only the genomic information, the clinical information, the MRI information and such, but also the environmental factors and the lifestyle factors. Those have never been included in the medical diagnosis. Rarely does your physician ask you, do you have a copy of your genome? Do you have a copy of your lifestyle and your diet and environmental and how close you live to it? That's never captured. And the other one that we never capture is the mental health related to individuals. We know that there's a relationship between the mind and the rest of the body, and we know that people have gone through massive restructuring of the body or dealt with diseases in ways that we don't understand. But
Pete, I just want to hear a story. Like, I am sure in the 12 years you've been doing this, you've changed some lives. And would you be so kind as to share just a story of where, because the doctor was able to access this expert system, either a person's life was
yeah,
changed and touched.
yeah. One of the ones that I like to talk about, and this is one of the more difficult, but yet one of the most rewarding things that we do as a business is I actually engage a lot with the parents. We deal with a lot of kids with rare genetic diseases, and this is a calling. This child, we'll call her Maria for this conversation. She was diagnosed with an autoimmune disease of the liver at age 2. So immediately the biopsy, the medications, the hospitalization. So 3 years into it, Maria is significantly worse, and the parents are broke. So through divine intervention, she winds up with Dr. Waringa, and he uses the technology that we have and very, very quickly diagnoses the case. 18 months later, Maria is thriving. And you know what the answer was to this child? The solution was change the diet, reduce the amount of protein, increase the amount of enzymes. And the kid all of a sudden, and the mother's going, if I would have known this 5 years ago,
Mm.
if I would have known this 5 years ago, and it just, one, the child itself, the financial conversation and the family disruption and everything else. This is what we're dealing with every day. There was another one that a child that had been having, she's 16 years old. She had been having dizziness for a long period of time. They go down to Costa Rica last year, it comes back, and the day after, all of a sudden, she starts having fainting spells, 16 fainting spells per day. And progressively, she's going to the different specialists and the geneticists and this, that, they're not getting anywhere. And then the kid starts having seizures. So now you got a 16-year-old in a wheelchair, cannot go to school, cannot attend, and everything else. And the mother is just absolutely fried. Finally, she winds up at Mayo Clinic in Jacksonville, and they were able to properly diagnose the child with a disease called POTS, which is a combination of the heart and the neural system. Okay, and it's a deficiency of blood. That's what causes the fainting as well. Um, I got to understand this case fairly well, and again, I'm not a physician, but I just put the variable symptoms into our platform. And when she calls me up and she says, it was diagnosed as POTS, and I turned the screen on and said, "This is what they said, right?" He says, "How did you do that?" I tell you what, it's the collective minds of very, very brilliant people that have produced significant amount of data, and all we're doing is compressing it, synthesizing, aggregating it, and turning it into actionable intelligence. The key word is actionable.
Mhm.
It's not just smart.
All right. So let's dive into expert systems. That's what you've described your technology as. And I'd hope if you could explain how it works, how it takes like the best of a highly skilled geneticist and pathologist and makes it available to more doctors and more people, not only addressing the rare disease problem, but also the medical desert problem. We have these four different things that AI can help with. I know lots of us will upload a imaging report into something, let's just call it ChatGPT, and we'll say, what does this mean? Or, ChatGPT, what do I do about my triple negative breast cancer? How is your system different from Dr. ChatGPT?
Very good. Very good. So a couple of factors. One, you got to be careful with the information that you put into a chat GPT or anything else. Consider that it becomes public domain, and then there's a sensitivity to your privacy and such. But the flip side is where things become very interesting. Consider that a chat GPT, a Copilot, any one of these systems is just scraping the whole internet for information. It could be relevant information, it could be non-relevant, it could be outdated, it could be misinformation. So you start getting the concepts of hallucinations that actually a given condition or a given recommendation could show up, and it'd be completely false. We know this not just in medical area, but we've seen it. Hey, read this book. The book didn't exist. So um, we haven't gotten all the bugs out of the AI, primarily because of the amount of data that is being shuffled. We concentrate on very, very trusted data that we either produce from our own analysis, our own AI, our own genomics work that we do, and or we license from trusted sources such as Johns Hopkins University, the NIH, the NCBI. So now we have both trusted from curated sources of data, but also that are just in time. That's the latest edition of a given data or a given article that has been published. So the moment you say, okay, it's trusted data just in time, and I have a longitudinal archive related to that data, then you actually start creating a much more trusted element. So we spend a lot of time one identifying the proper sources of information. So just like we did in the genomics work related to Johns Hopkins, probably has the best source of rare diseases data. It's called OMIM, the Online Mammalian and Mammals Database. We do the same thing for cancer. We do the same thing for cardio, for neuro, and such. So, in essence, what you're doing is bringing in the best minds from multiple sources and integrating.
So It's a classic garbage in, garbage out, right?
Absolutely.
People are still going to go to Perplexity or ChatGPT or Claude
Hmm.
or even
Hmm.
Google and
Yep.
say, here are my symptoms, or here's my diagnosis. What should I know? Because frankly, consumers don't have access to your system. Your system is for
Correct.
professionals. So, what would you tell a patient? You're talking to them now. What
Hmm.
should they be aware of in what they're getting back from whichever of
Yeah.
these systems that they're saying, oh, we get the privacy thing, great, like, but this is what I've got, and people are very anxious when they suspect or they hear it's cancer.
One of the areas that we're putting an awful lot of heat and attention is bringing the medical community up to date in terms of the AI platform, the trusted AI platform. So we're developing everything from continuing medical education courses for physicians on AI, taking the guesswork out of it, and providing in medical terminology trusted factors that they will both get medical credit for, but bringing them in. We don't want to make a physician an expert on AI coding. We want them to use it and use the proper tools. We don't want them to become geneticists or oncologists, but we want them to use the black box in a very secure and privatized, personalized way to actually deal. Now, the question to you and I, an individual, how do we deal with this thing? A couple of things that I always recommend. First, um, trust, validate before you trust anything. The second one is drill a whole lot deeper, so it's not just a very, very basic set of questions. The more data you provide and the tighter you define the problem, the better answer you're going to get related to it. Consider that, especially in cancer, this is not a one gene, one disease, one everything else. It's a multiplicity of factors that are being integrated and coinciding at a point in time. So consider in the case of cancer, um, there is a genetic predisposition. There is some symptomatic issues related to it. There are some trigger effects that could be environmental, it could be lifestyle, it could be trauma. So all of those can go into the mapping. That's actually how we're training the system. You got every large language developer right now trying to get into the medical space, but they're actually showing their lack of knowledge in terms of the medical world. And the thing that you got to be very careful with is if you create an imbalance between the consumer and the physician, the clinician, because one could be ill-informed or much more informed than the clinician, and then you create a balance. We saw that with the advent of Google, and we saw with the advent of WebMD, that people would show up with the physicians that I have the following. The physician is going, I don't know how you came up with that and such. So what we're working on is language models that can bring together the consumer with the clinician, with the scientist. In other words, a universal translator going into the core engine where I can ask a question in natural language. I have a headache, I have a rash, a skin, or everything else. The clinician understands it in medical terminology, which is very, very different from consumer terminology. They use very long words, they mumble, and so it's medical terminology. A scientist uses completely different terminology. A geneticist, it's a language of their own. However, if they're three interacting with the same brain, the same AI, in using the terminology, now you got a translator that is actually simplifying and accelerating the communication and creating the much more trusted factor in terms of the relationship.
Okay. So, could a patient ask their doctor or their team, are you using SIVOTEC? What is it they should ask their doctors to consider?
Yeah, very good. So consider that for the most part, a specialist. And this is one of the limitations of how we've fragmented healthcare. It's we have created specialists that only concentrate on a very, very small part of the body. Well, the body doesn't work that way. The body is a set of integrated systems, all having trying to reach some kind of equilibrium, some kind of balance related to it. So the first thing to ask a physician, you pretty much know what kind of answer you're going to get based on the specialists you go through. I always use the example is if you're having a tough time breathing and you go to a podiatrist, you're going to walk out with insults no matter what. It's the tools that they have. So one is the multidisciplinary approach, and this gets back to one of the earlier questions that you asked. It says, why does it take that long to come up with a diagnosis, even if it's a simple type of condition? Well, it's trial and error. Medicine is still to the much, for the most part, trial and error. Well, let's try this. Let's try this specialist. Let's do this test. Let's do this test. There's no comprehensive you represented into the world of the specialist because they're only picking up limited amounts of information. This is why we think the AI is going to expand much, much better what the totality of view is. So part of the equation to your physician is how did you come up with that data? More than one time, I've sat with patients or friends. They went into a physician, and I'd said my son has the following, and it says something 23 letters long. And the physician stared back and then all of a sudden tried Googling to see what was that. And my friend just walked out with her son right out of the equation because they said, are you kidding me? So we're putting an awful lot of stress on the medical industry right now to we're actually providing tools like the platform that we developed called Gina. Gina is your genetic analyst. And what we started doing was originally testing it out with the geneticists of the world. Why the geneticists? Well, you got to prove the science first. Unless the geneticists say, yeah, that's good. So the 160,000 cases that we've done have been with geneticists actually using a platform. So we said, that's cool, but there are only 3,500 geneticists in this country. There are 1 million non-geneticists that are pediatricians, primary care physicians, and specialists. How do we bring them into the world by not necessarily making them a geneticist or an AI specialist, but give them a tool? So the next iteration that we just launched of the Gina platform, without having a genetic test, just by putting the clinical symptoms, the phenotype, you can actually describe X number of type of conditions and determine if you have a potential genetic disease.
Interesting. Interesting.
Very, very interesting because that changes the game because that's actually what a primary care physician is looking at. Well, what if you could actually just do from a screening perspective, just on the clinical symptoms that you're observing, what if you could say, we got enough information here that it is potentially a genetic condition, order a genetic test to validate. And second, here's the type of specialist that you should talk to because it was probably a combination of a neuro, an audiology, and an orthopedic. Well, which one do I go to? All those were symptoms. They were not root cause. So one of the key areas that we're really, really pushing on the AI is what is the root cause of this problem?
Mhm.
For the most part in medicine, we treat the symptoms, the after effects, and we're masking the root cause. So let's get to root cause because the quicker we get to that, a lot of the symptoms start going away.
That's very powerful. And it's also powerful to rule out, right? Like we don't need to do
Exactly.
excessive. Now,
Now, but yeah, don't leave that point
okay.
because the basic cost and why we have such an expensive medical system right now is the amount of unnecessary testing that we do in the trial and error format. So we're torturing somebody. A kid with a rare genetic disease, on average, it takes 5 to 7 years to diagnose.
Wow.
Okay, 5 to 7 years of biopsies, testing, hospitalization, medications, and everything else. And what we're seeing with all of these is, one, the progression of the disease is monstrous, over 5, 7 years, given a cancer, metastasizing during this period of time. But then the second thing is the financial impact on the family as well. Most of these people, by the time, they diagnose the kid, the parents are broke, many of the times divorced, because the amount of stress that it caused upon the family was just absolutely horrendous. So we're going after the tough ones. Cancer is a tough one, but the only way we're going to get to it is if we start understanding many, many more variables than what we're dealing with today.
That makes a lot of sense. So you've mentioned you have to prove the science works, right?
Mhm.
Pete, my understanding is you're not a doctor. You didn't come up the medical world. You were at IBM for many, many years, and you're come up the technology world. So tell us a little bit about the scientific advisory board. Is Gina something you cooked up in your garage, or like where does this come from?
Believe it or not, it was started by a geneticist for geneticists. So it was actually a Dr. Klaus Waringa, who's now our chief medical officer. He's also the head of pediatric genetics at the University of Florida. And what he was doing on average, it was taking about 3 or 4 days for him to properly diagnose a case. There's so much data in genetics, it's absolutely wild. So we started codifying his thought process. He actually had a very, very specific way he was looking at microdeletions and microduplications in terms of the chromosomes and stuff like that. So we actually put it into algorithms and developed it. My job is to bring best scientists, best engineers, best entrepreneurs, pull them together, shake it up, stress them big time. So now we have the linkage between the science, the application related to the technology, the formalization, but the path to market, the commercialization. Make it incredibly simple. So it says the things you're observing, you either speak or type into the system, and the thing in real time comes back with answers. Then we're not saying this is a diagnosis, it's clinical decision support. The decision is still upon the physician to make, but we're providing them a whole lot more data that is being synthesized for them to actually analyze. And it's relevant, it's trusted data, so it makes it a whole lot quicker.
Okay, that's great.
What do you do with this stuff?
Fantastic. All right, let's do the lightning round. Complete this sentence. The biggest mistake patients make when facing a complex diagnosis is.
Trusting the health system without question. I think there's a lot that can be done there, and yeah, it's trust but verify.
I often tell people, you are the quarterback. You're building the
Exactly that. The
team, but
CEO. Yeah,
you are the
exactly.
quarterback. You got to run the play. What
Yeah.
is one myth about AI in healthcare that you want to bust right now?
That it's producing 100% answers right now, and that you should rely on it. We're not there yet. I think we're making tremendous strides, but I would be very hesitant to take as a golden rule, especially as it relates to your health. That it can produce a better report or analyze some things, yes, but healthcare is complex, and trusted data is very, very key.
Okay. If a patient's doctor dismisses their request for genetic screening or more comprehensive testing, what's your advice for how they can move that needle?
Walk away. And we've seen this, and this is very, very interesting, because this starts bringing in some of the ethical concerns related to both AI and genomics and the future of health. You have to give them the right to choose and everything else. And the mother's saying, "Are you kidding me? My husband died at age 42 from cancer. I'm an Ashkenazi Jew. I know that there's a familiar thing. You know what?" And the doctor is saying, "I don't." I said, "Walk away." Walk away, because one, it shows a level of lack of confidence in terms of what they will prescribe, lack of understanding. So it just means you got to do a little bit more work. But if somebody is reluctant to find out more on your behalf, or on behalf of your child, and just be closed-minded about it, walk away.
Okay, two more questions. Your technology has helped diagnose 162,000 people. primarily children with rare diseases. What's the one thing that gives you hope about the future of cancer diagnosis?
Yeah, that we're expanding way beyond rare diseases right now. We're using the same platform now and teaching it a whole lot broader. So from 7,300 diseases, now we're looking at 25,000 diseases. The second is we're amplifying from children now to adults as well. And third, that we're being able to bring a whole lot more data. We started off with just the genetic information and the clinical information. Now we're bringing environmental, we're bringing lifestyle information, we're bringing trauma information into a really, really heavy duty model. So when we showed this to some of the heavy duty folks in the medical world right now, and we've asked them bring real life cases into this thing, put it into the engine, and see what comes out. They have walked out scratching their head and said, "I had not thought of that. This is really, really heavy stuff," and we're dealing with the top ones. So there is hope. We got a lot of work to do because we're dealing with live bullets here, but yeah, no question about it. Because what we're doing is amplifying the brain to be a super brain of taking a look at the whole human body as an entity, not in very fragmented pieces.
I think that's amazing. Okay, what's the one piece of advice you'd give to somebody about how they could kick cancer's ass?
You mentioned it. It says you become the quarterback. Assume that nobody else is going to worry about you the way you worry about yourself. So educate yourself. Converse. There's support groups. There are intelligent groups. There are systems. There's software.
Come
There's
on, tell them to subscribe to
data.
this podcast.
Subscribe. That's where I was going to end with. But the point is, don't become a victim. You actually got to get in front of this thing and take it on. And one, I admire you for what you're doing. The support systems, which are the eye openers for most people, because it's, I had no idea. How
Right.
do I contact them? What do I do? And whatever. So I've seen these support groups work incredibly effectively for children, for cancer patients, for mental health, for all of the above. And so God bless for what you're doing.
Oh, thank you. I really am committed. I don't have the technology and the scientists. I'm committed to helping people change their mindset into the mindset of someone who has hope, has knowledge, and is going to unleash the power within them to kick cancer's ass. Pete,
Well, we're all playing a different role here. We're all grabbing an oar and going in try to go in the right direction. So yeah, we're all here on the same team.
absolutely. Pete, thank you so much. You've been a fabulous guest. I hope that people learn something about the 4 different things we can use AI for in the scope of genetics and cancer, and that they're going to advocate with their doctors to push on screening, get more knowledge, and that many, many, many more doctors are going to take advantage of things like Gina to make it easier. Because the key to cancer, at least, is what you diagnose early you can treat way more effectively. So everything we can do, whether it's Gina, whether it's liquid biopsy, whether it's
Yeah,
better imaging, I don't care where it comes from. If we can catch these things early, we can obliterate them.
completely agree.
Thanks for being here.